Hello, all. We shall talk about the derivation of Doppler shift. So Doppler shift is a very important in case of radar target velocity determination. And the final equation of Doppler shift FD or Doppler frequency shift equals to twice VR by lambda, where VR is the radial velocity of target with respect to the radar, and lambda is the wavelength corresponding to the frequency of operation of the radar. Now say here is our radar and it transmits some frequency. That frequency hits our target, say aeroplane, which is moving at a radial velocity of VR, and we receive the echo. So this is our transmitted frequency FT. This is our received frequency FR. It is our frequency FR. So the frequency which would be sensed by a frequency meter in the target is say F target. Okay. If the target echo, this one is considered to be from a signal generator, assuming a signal generator in the target itself, then this F target is the signal generator's frequency. Okay. So the total one-way phase from the radar to the target would be 2 pi by lambda t into the range, where lambda t is the wavelength of transmitter. Okay, of transmit. So why this one? Because in for lambda t wavelength, when we traverse a wavelength lambda t, we traverse twice 2 pi phase. So 2 pi by lambda t into r would be the total phase, one-way phase from radar to target. Okay. Now we have already said key F target is the frequency that the frequency meter in the target is seeing, right? But if your target is moving, then this F target value will also be changing. Okay, how? So our F target equals to the transmitted frequency Ft plus this change in the F target value, right? So F target is the frequency of illumination seen by the target. So Ft is the corresponding to lambda t, the frequency transmitted by the radar. Delta F target, this one, is the frequency change due to motion. Okay, due to motion. So we can say the frequency change caused by the target's motion is the cycle equivalent of the time rate of change of total phase. So 1 by 2 pi of d phi t by dt. But phi t is already this value. So we can write we can write del d phi t dt is equal to d dt of phi t, which is 2 pi r by lambda t, equals to lambda t goes out, 2 pi goes out because they are constant, dr dt. But dr dt is nothing but the radial velocity, because that is the rate of change of range, direct range, straight range, in the line of sight range. Yes, rate of change of line of sight range, that is our radial velocity. So this will be 2 pi by lambda into Vr. So this equation now becomes delta F target equals to 1 by 2 pi into 2 pi Vr by lambda, thus only Vr by lambda. But our F target is Ft plus delta F target. So F target will now become Ft plus Vr by lambda. But as F lambda equals to C, so we can write, and here the lambda is corresponding to our transmission wavelength. So this is lambda t, this is lambda t, this is lambda t, lambda t, this is lambda t. So our lambda t is equals to C by Ft. Thus this will become Ft plus Ft into Vr by C. So now we can think of the target as if the target is now transmitting this frequency F target, and our receiver will receive whatever this frequency is and whatever the change is due to the motion, right? So now the radar receiver frequency, the receiver will see this F target plus whatever the frequency change in frequency will be there because of the motion of the, there is a change in relative distance range in between the target and the radar, as previously done. So here we can again, using previous derivation, we can see that delta FRDR is nothing but delta F TGT, which is equals to d phi t dt into 1 by 2 pi. Okay, this one by 1 by 2 pi. So we can from here, so now we can write the received frequency as F target, which is Ft plus Ft Vr by C plus delta FRDR, which is this one, which is nothing again but Ft Vr by C. So this is Ft plus Ft into twice Vr by C. This is our received frequency, or we can also write it like, received frequency Fr equals to transmitted frequency Ft plus twice Vr by lambda transmitted wavelength, lambda t. Now this twice Vr by lambda t is our change in frequency, and this is our Doppler frequency. So this is the Ft minus Fo. So if we do if we do ft minus fr, so if we do ft minus fr, that will give us our Doppler frequency, which is nothing but twice Vr by lambda t, or ft into twice Vr by c. Okay, so that's the derivation.